So the fear of machines, or the symbiosis, this entanglement with machines and software, essentially, especially in young kids growing up with all of this entanglement as part of their entire life, that it will somehow divest us of some part of our humanity, turn us into people who can only live with the technology. And what happens when there's something like the big denial of service attack that happened a week ago, where
Yes.
still haven't heard who did it and
I
why.
don't know.
And it shut down, I don't know, Twitter, it shut down this DNS company, and it shut down Twitter and some other ones, and we
Right.
still don't know why or what or who, and is that just a practice for a larger one? And what happens when someone else, another outside power, shuts down our entire internet? What can we function under those circumstances?
Oh, yeah. Well, in many ways, Danny was right by calling it the connection machine.
Mm.
It wasn't the processors, it wasn't the memory, it was the connections. And the connections grew out of the box into the internet, the ARPANET, the internet. And so it's this interconnectedness between people, between machines, between organizations. That's the real power of it all. And that was an amazing insight. I mean, who out of a computer would go and stare at the wires and go and say, it's the wires that are important, right? Or if you look at the American economy, who would go and say, it's the roads, right? I mean, it's just, it took a different way of thinking of it all. And what happens when we turn this sort of thing off? And how dependent are we on it? And it's extremely. I don't know how long our food supplies would last if any of this stuff really was majorly disruptive. And now, as we now know because of Edward Snowden, governments are actively not only surveilling, they're actively out to control what's going on. So these are state actors. That not just script kiddies or spammers from Eastern Europe trying to make some bucks off of causing you to buy fake Viagra. We have a whole nother level of interplay that's going on, and so the blessing and the curse of it is we are building a global brain. We're all part of it, but it requires a trust. It requires a web of trust, and mostly in the last 20 years, we're 2016, the Internet Archive just celebrated 20 years of a web archive of showing how people have come together to build and share in ways that when I was growing up, people just wouldn't do. There was just this sort of McCarthy era sort of keep your head down, be careful what you say, just know who your friends are and who they aren't. And but then there was this, let's build something bigger that came over people. And it was all of this interconnectedness of computers. And it's the connection machine writ large. And there is, in fact, quite direct connections between the sort of connection machine and the internet of machines, of people, that evolved. But we still haven't solved some of the basic problems. And we'll see how we get through it. Do we actually keep sort of our meaner instincts under control?
So, a couple of things just there. One, if you could talk about what do you see as the direct legacy of the connection machine
Sure.
and the internet of today? And the other question, what should we be doing as citizens to shape the future so that it is positive for humans and not, say, a Big Brother scenario, and not a scenario where essentially so much is built into algorithms that we no longer can trace back and find out, well, who is deciding that, I should go to jail, or my child should go into foster care, or all of these decisions that might somehow become not only
Algorithmic.
Pardon?
They'll become algorithmic.
Yeah, and that's a level of on top of the existing bureaucracy where then people say, well, you know, it wasn't my decision, the machine learning algorithm is the one that evaluated that, and I can't question that because I have no way to reach into that system.
So the connection machine and thinking machines evolved into becoming sort of what we think of as the modern internet, and in an interesting way. So there's the connection machine, which by the time we had the connection machine version 1, we could load up all of the published works in these huge databases. All the magazines and newspapers at Dow Jones would come together to make a search engine. The very first modern search engine was built out of a connection machine, Model 1. And then we built the Model 2 to be even a better search engine. Then we needed to make it so that people could contact it. And I did a project called WAIS that was at Thinking Machines. And Danny went and talked with Alan Kay at Apple, Bill Dunn at Dow Jones, KPMG, Pete Marwick, the professionals. And we put together a project. And I ran this project. It was a precursor of the World Wide Web. It came before the World Wide Web, before Gopher. It was the first client-server system where you could turn on a computer, an early Macintosh, to go and ask questions in English. In English. This was radical. And contact a machine that was thousands of miles away, ask it a question that comes back. Now let's ask this other computer question and come back. And the idea of that is what a role of a connection machine was born at Thinking Machines. And so the first client server, what then really evolved into the web. It was being developed separately in Sweden, in Switzerland, but definitely was mosaic of NCSA before Netscape, was a mosaic of WAIS, World Wide Web, and Gopher. And those systems were put together to make what became the World Wide Web. And so the thinking at Thinking Machines was far enough ahead because we could see the future because we built these machines that were $1 million machines that we knew were going to be tiny. But Danny always had this idea of, let's keep thinking big. And it's like, oh, it's great that these machines are now the size of watches, but what's the machine that's big again? What's the warehouse size machine? And that traversal was actually some of the direct computer architecture. We started with these tiny processors, 64,000 in the connection machine Model 1. And more or less the connection machine Model 2 had these larger processors. By the connection machine Model 5, they were even larger processors that were starting to be operating independently from each other. By the time the next generation, which was sort of Yahoo or Alexa Internet, the Internet Archive, Hotmail, those were all built out of self-similar computers stacked on top of each other. That was the architecture of the future. When Alexa Internet, company that I started, which we had built this sort of connection machine-like thing to scale, we were bought by Amazon.com because they needed a solution. They were still built out of these old clunky things. And they said, how do we do this? More or less, direct cause and effect is always a little hard to exactly figure out. But the Amazon Web Services, EC2, S3, it all looked like that same brick style that we brought in. So the connection machine all the way through to the Googles, the Amazons, now the Apples are sort of come through that legacy of thinking of how do you interconnect machines, how do you interconnect people. That was done back in the 1980s at Thinking Machines.
Yeah, and Danny mentioned in the interview that I did with him that Sergey Brin, who started Google, got his start as a student programming the CM2 and the connection machine Model 2, and that took the programming paradigm that you guys had developed for working on the connection machines and made a version that he called MapReduce, which became the basis of Google search, and also incorporated Danny's second company, MetaWeb, in 2010. So it seems like there's some strands where there's a very direct lineage from the connection machine. But it's interesting to hear that you're saying that the way of thinking that led to the web was also something that that perhaps in parallel was happening in different places, but you guys were certainly a part of it at Thinking Machines.